Section 5.6 video, part 2. We're continuing with our part on factoring trinomials, but we're talking about factoring trinomials of a specific form. And I'll remind you of that as we write this first problem down. So the instructions here, factor. All right, number 1. Let's do x squared plus 11x plus 28. Okay, before we just jump straight into this problem, let me make just a couple of comments. Remember, the first thing you do in factoring is you always look to see if this problem has a GCF. It does not. This problem does not have a GCF. And by the way, this needs to be 11x. I left off the x. X squared plus 11x plus 28. X squared plus 11x plus 28. Let me rewrite that. All right, so there's no GCF. There's nothing that goes into every term. Okay, we said that all of the trinomials of this type, if they factor, they will factor as a binomial times a binomial. All right, so let's break up the x squared. Well, that's easy. X times x. All right, the next thing I do is I look at this sign right there. If this is a plus, this tells you the signs down here are the same. If this is a minus, this tells you the signs down here are different. So what does this mean right here then? It means the signs are the same. Now, what does this tell me? This sign tells you what they're going to be. So this tells me that they're both positive. So I can go ahead and put a plus with both of those right there. Now I've got to fill in the last two spots. Now if you will point to it the way I'm about to show you, you won't ever go wrong here. All right, watch. To fill in the last two spots, you ask yourself two questions. Question number 1. I need two numbers that multiplies to give me 28. Well, that's 3 options. 1 times 28, 2 times 14, and 4 times 7. So that's 3 options. But there's a second question. Those same two numbers, watch, has to add together to give you 11. So watch one more time. Multiply 28, add 11. Well, now that rules out 2 of them. What 2 numbers, if you multiply them, gives 28, but if you add them, you get 11. That would be 4 and 7. No, it does not matter which one you put where, because x plus 4, x plus 7 is the same thing as x plus 7, x plus 4. As long as what's in the 2 groups, the 2 parentheses are the same. Now, is there any way we can check this, see if we really did it right? Absolutely. If I FOIL this, x squared plus 7x plus 4x plus 28, which is x squared plus 11x plus 28. Okay, let's do another example. So let's look at x squared plus 16x plus 28. A trinomial of a specific form. This is the easy case because there's no number in front of the x squared other than the 1. All right, so how do we factor this then? First thing we do is look for a GCF. That doesn't work. You say, well, let's try grouping. The grouping's not in play because all of these are going to be trinomials. So grouping is not even an option. So I told you if a trinomial factors, if it doesn't have a GCF, if it factors, it will be a binomial times another binomial. So how do we break up the x squared? X times x. What does this tell me? Now, don't look at both of these signs at once. You look at just that sign. What does this tell me? If that's a plus, that means the signs have to be the same. They're either both plus or they're both minus. Now, what does this tell me? This tells me what they are. So signs are the same, both negative. Now, how do I finish the problem? To fill in the last two spots, you have to ask yourself two questions. What are the two questions? I need two numbers. When you multiply them, you get 28. Well, that's 1 times 28, 2 times 14, and 4 times 7. But those same two numbers has to add together to give you 16. Multiply 28, add 16. Well, 4 and 7 won't work, but 2 times 14 will. And if it helps you, a lot of times, I've seen students come to the side, they'll do 1 times 28, 2 times 14, and then 4 times 7. Two numbers that multiply 28, add 16, of course, is 2 and 14. Since the signs are the same, it does not matter which one you put where. Could I double check this? Absolutely. If you FOIL this out, it will take you exactly back to where you started. All right, now, I do suggest when it comes test time that you always FOIL your answer back out. I won't in here just for the sake of time, but I will remind you that you can check your answers. Okay, so let's look at this one then. M squared plus 5m minus 14. All right, first thing I look for is the GCF. This does not have a GCF. There's nothing that goes into all three of these. Grouping is not an option because this one has 3 terms. So this is a trinomial. It's the easy case because that's an understood one. If a trinomial of this type factors, it will be a binomial times a binomial. So m squared breaks up m times m. Now, what does this tell me? You got to multiply two numbers together to get a negative 14. Well, if you're going to multiply two numbers together and you get a negative, one of them's got to be positive, one's got to be negative. So this means the signs are different. One's a plus, one's a minus. Now, it doesn't matter whether you put the plus first or the minus first. Doesn't matter. It will matter what you put behind these two. So, we'll talk about that in just a second. So, here we go. All right, I got 2 spots to fill in. So, to fill in the last 2 spots, you have to ask yourself 2 questions. What's the first question? I need 2 numbers that multiply to give me 14. Those same 2 numbers has to subtract to give you 5. Multiply 14, subtract 5. What are those 2 numbers? 2 and 7. So you got a 2 and a 7, but one's positive, one's negative. Now, since this 5 is positive, that means that your largest number has to be positive. So this means that the 7 has to be behind the plus. And the 2 has to be behind the minus. Because see, a plus 7 and a minus 2 is a plus 5, but if you multiply them, you get negative 14. So this tells you the signs are different. This tells you that the largest one will be behind the plus sign. Now, if your plus is over here and your minus is over here, then you would have m minus 2, m plus 7, which is the same answer as well. Now, the m plus 7 must be together. The m minus 2 must be together. Okay, let's look at another one. P squared minus 11p minus 12. P squared minus 11p minus 12. All right, what's the first thing we look for? GCF. This doesn't have one. Next, grouping. Grouping's not in play. So the only other option is for me to do my two sets of parentheses. Okay, how will the p squared break up? That's easy. P times p. All right, now what does this tell me? This tells me that the signs are different. So that means one's a plus and one's a minus. This tells me the signs are different. If that's a plus, it means the signs are the same. So the signs are different. What does this tell me? It tells me that the biggest number is this. So the signs are different, biggest number is negative. So my biggest number is going to go right behind that minus. All right, how do we figure out the two numbers? Ask yourself the two questions. Watch how I point to it. Two numbers that multiply to give you 12, but if you subtract them, you get 11. Multiply 12, subtract 11. What two numbers, if you multiply them, you get 12, but if you subtract them, you get 11. 1 times 12. 1 times 12 is 12, but if you subtract them, you get 11. But the largest has to be negative. So your 12, your 12 is going to have to go here, and your 1 is going to have to go there. Now, just to show you, if you FOIL this out, p squared minus 12p plus 1p minus 12, which is p squared minus 11p minus 12. If you put those signs in the wrong place, you're going to end up having a plus 11p. So, all right, let's look at another one. Y squared plus y minus 20. Okay, first, look for a GCF. This doesn't have one, so that's out. Next, if this is a trinomial, if it factors, it will be a binomial times itself. All right, so y squared breaks up as y times y. Now, what does this tell me? This tells me the signs are different. So that means one's a plus, one's a minus. What does this tell me? This tells me that the largest is positive. So my biggest number is going to go right there, behind the plus. So how do I finish the problem? You ask yourself, you got two blank spots, you ask yourself two questions. Here are the two questions. Two numbers that multiply to give you 20, but subtracts to give me, remember, understood 1. 1. Multiply 20, subtract 1. What two numbers, if you multiply them, you get 20, but if you subtract them, you get 1. Well, if you have trouble doing that in your head, come over to the side. 1 times 20, 2 times 10, and 4 times 5. Which of those two numbers, if you multiply them, you get 20, but if you subtract them, you get 1, 4, and 5. But the largest number needs to be positive. So you have to put the 5 behind the plus and the 4 behind the minus. And that's your answer. And yes, again, if you FOIL this out, it will take you right back to where you started. Okay, let's look at another one. show you, this one looks a little different. Now you say, wait a minute, this one's different because it's got a y square on this end. That's okay as long as it has a y in the middle. So see right here, if you got an x square on this end, what do we always have in the middle? A x. So if you have a y square on this end, what do you have to have in the middle? You have to have a y. Now, that's not going to affect what numbers you choose. I'll show you that when we go through this problem. All right, so here we go. First, look for a GCF. Is there anything that goes into every one of these? Is there an x in every term? No. Is there a y in every term? No. So there's no GCF. Well, this is a trinomial. It's going to be the easy case because this is understood one. So I'm going to do my two sets of parentheses. So x squared breaks up x and x. Now let's talk about the signs. What does this tell me? This tells me signs are the same. What does that tell me? This tells me what they're going to be, both plus. Now I've got to fill in the last two spots. How do I do that? To fill in the last two spots, you ask yourself two questions. Two numbers, if you multiply them, you get 15. But if you add them, you get 8. Multiply 15, add 8. Well, that'd be 3 and 5. They're both plus, so it doesn't matter which one you put where. Now, here's the only difference. When you break up this x squared, didn't it break up x and x? Yes. So when you break up the 15 y squared, you're going to break that up with a y and a y. So the only difference is you got to put a letter behind both of these numbers. Now, let's check it and see if this works. Check my time. Okay. Let's check it and see if it works. So we've got x squared plus 5xy, or 5yx, however you want to write that, plus 3xy plus 15y squared, which is x squared plus 8xy plus 15y squared. And if you will notice, that takes me right back to where I started, which means that this problem is factored correctly. Okay? Let's look at another one. M squared minus 12mn minus 14n squared. M squared minus 12mn minus 14n squared. So let's do this one, and that'll close out this video, and I'll do some more examples in the next video. All right, so first, look for a GCF. Is there an m in every term? No. Is there an n in every term? No. So, this does not have a GCF. Okay, if it doesn't have a GCF, then the next thing that we do is break it up into two sets of parentheses. M squared is m times m. All right, what does this tell me? It tells me the signs are different. That means one's a plus and one's a minus. Now, what does this tell me? It tells me the biggest one will be negative. So my biggest number is going to go right there. All right. So how do I fill in these last two spots? You ask yourself two questions. I need two numbers that multiplies to give you 14. So let's see, 14. That's 1 times 14. And then 2 times 7. I'll tell you, there, let's go with this. All right, so question. Are there two numbers that multiply together to give you 14, but if you subtract them, you get 12. No, there's not. So what does that mean then? It means this problem cannot be factored. So we call this prime. Or non-factorable. So see, not all trinomials are factorable. Now in the next video, I'm going to rework this problem and I'm going to change this one number and show you how this problem now becomes factorable all of a sudden. But we'll look at that in the next video.